Um, so I'm going to talk about the wave current interaction effects on renewable energy in general. And this is a collaboration work, so we are a team of 5 people. In this particular work are my colleagues Simon and Alan Davis. So Peter Robbins also and Matt Lewis are working with us to consider the wave current interaction effects. So what I'm going to present, I'll have an introduction about wave current interaction and why we are studying them and what's the importance of them. And then I'll present a very simple method to include them in a wave resource assessment. So in general, if you look at the map of the global wave energy, you will see that the UK shelf seas are in a very unique and good position in terms of wave energy resource. And at the same time, you will see that it's also very good in terms of the tidal energy. So it says that this region has like a unique position in terms of the interactions of the tide and wave resources. So traditionally, if you look at the work which has been done, generally the work, the tidal, I would say people, they might ignore the tide or the wave. People, they don't consider the tide in general kind of practice. So I'm going to talk about the interaction of them. So if in terms of like a physical process, simply tides can change waves. So a very simple thing is that if you have tidal currents, they will change the frequency of waves. That we call it Doppler shift. And they have other effects. So if you have a vertical tide, so it means that you are changing the water depth, and it means that you are changing the wave propagation. And so there's the other way around effect, that if you have waves, the waves are going to change the tide as well. So in this presentation, I'm just going to talk about the effect of tides on waves. So we have done another work on the effect of waves on the tidal power, which hopefully are going to present it in other kind of meetings. So before I start to talk about it in like a technical aspect, I was going to say that if the wave current interaction is important, so it would have some implication in the device design, in the resource assessment and environmental design, and finally in the social and like the economic aspect of a renewable energy project. So this is I'm more specifically in the design of a specific mechanical design of device and the environmental loading and resource assessment. So in terms of the technical aspects of the wave current interaction, so we used a very simple method to quantify it first. So if you look at a very simple regular wave that we know everything about this wave, so it's a very sinusoidal, simple harmonic wave, and we have all the properties. So it's very small because it's very complex. It's a lot of equations. So if you consider this harmonic wave, we could superimpose a vertical and horizontal tide or water elevation change as well as current change. And what we have done is that we computed the wave energy, this simple wave energy, without and with inclusion of this tidal, vertical and horizontal tide. So this shows that we know everything about the linear wave or harmonic wave. We know how the particle moved. We know the hydrodynamic field and everything. So whatever we say, it's exact about this. So this is this equation simply shows the wave power of a harmonic wave. So generally, I mean, the wave energy is dependent on the wave height and the speed of the traveling of waves. So we call it group velocity and wave height. So if you superimpose the tide, the first thing that you will see, there's a significant change in the propagation velocity of wave. So we call it Doppler shift. There is also a change associated with the wave height. So, but this theory cannot consider that. Just if you consider the effect of tide on the wave speed, what's going to happen based on this simple theory? So these graphs, there are like 4 graphs for 4 tidal current speeds. On horizontal axis, you'll see a kind of normalized water depth, and in the vertical axis, you will see the vertical tide. So for this scenario of 1.5 meter per second tide, like a peak tide, tidal currents, you'll see that there are like effects of about 10% in the water depth that we are working on the wave energy, if you just consider the effect on the velocity. So what we have done is that we applied this simple method to the UK shelf sea and examined what would be the consequence of the wave current interaction on the wave resource assessment. So this graph shows the variability of the wave power over the European shelf or UK shelf seas based on the Simon and my work. And this is the study area. And we selected like a month as a typical energetic month, which is January 2005. And then, we developed a 3D tidal model of this region and a decoupled Swan model of the region. So what we can do using the graphs that I showed, we have a tidal vertical tide and horizontal tide at each single point over the European shelf seas, and then we can compute the effects on the power. So this is like a vertical tide, horizontal tide, tidal ellipses, and the wave power. So it's based on Swan and Rom's regional ocean model. So what you will see is, so on the left plot you see the wave power in this January 2005. And on the right, the effect. So based on what I've done, I mean, I've seen, or on this plot, you will see up to something like 10% of the effect on the wave resource. And in particular, the regions on the northwest of Scotland and Pembrokeshire are and also Orkney are the places that the wave current interaction effects are dominant, I mean, this whole region. So the other thing that we have done is that we assumed, so the theory that I described, there's another variable which is wave period. And this is the sensitivity analysis about the wave period, and simply it shows that the effect decreases as you increase the wave period. So it means that if you have a lower energy wave, the impact is higher, simply. This approach that I just described, it has its shortcomings, and I'm sure many people in this audience, they might think, okay, there are lots of assumptions on linear wave theory and you can't apply it. For instance, as I mentioned, the effect of the tides on the wave height cannot be considered based on the linear wave theory. So at the final stage, we used a sophisticated coupled wave tide model in which the wave car interactions are included inherently in the model. COAS model, which is a combination of Swan, Rams, and Wolf model. So this graph shows that if you want to use a coupled tide and wave model, it's complicated. I mean, because there are many processes between wave and current model, and there is not much observational data to select the proper physics in these models. But however, I examined the Swan model results on wavebuoy sites in which the wave car interaction is important, which is in Scarweather wavebuoy, which is located in Bristol Channel. So what I was surprised a little bit that the model performance was increased. I mean, got much better. I mean, it increased about 25% when I included the wave car interaction, because there was a modulation of tide in the wave properties. So I mean, I'm sure it's going to be more than 50% improvement over the tidal wave energy if you include that. So if you look at the model results, you'll see that there is not much difference between a Swan and COAS coupled model, but if you subtract the results, you will see again. So this is based on a sophisticated modeling again. So the results are similar to what I showed you based on linear wave theory. And again, the northwest of Scotland and Orkney and west of the Islands are places that wave car interactions are important. So there is another study which has been done specifically for Orkney and has shown the impact of wave car interaction as well. So in summary, what we argue is that the interaction of wave and currents, specifically in the UK shelf seas, and in that region, specifically north and northwest of Scotland, are important, and also in Pembrokeshire. So the currents are main source of the error if you ignore them in wave and resource assessment. And the impact would be higher in places that you have lower wave energy. And finally, you need a high resolution coupled model for a specific region to quantify this effect. Thank you.
Do you have any questions for Reza?
Yes, please.
Yeah, really like to debate that. I just wondering, did you, with your two-way coupled model,
Yeah.
did you find the same effect with regards to period, or was there some variation in the...
Yeah, that's a good question. The thing is that I haven't examined that in the coupled model yet, because the wave period is variable over a domain. So I think it could be considered if I consider some idealized wind scenarios in that case. But the real wind, because the variability of the wind is high, variability of wave period, I haven't examined it yet. But I suppose it would be the same. Yeah, but that's good thing to consider.
We take one more.
That's good.
The conclusion here is the tide or current flows can significantly alter the way climate is. I think that's what people who study weather interaction expect.
Yeah.
In terms of the actual method of approach here, presumably you maintain other calibrated parameters in the slow model
Yeah.
the same in both runs. There's no attempt to look at the variability of the different the other calibration parameters.
Yes.
Or you just fix those and then
Yeah.
look at the impact of those other parameters.
Yeah. I mean that's a good question, because you can improve a model by calibrating it, or you can include more processes in it. And I mean, there was like two talks before this one about a high resolution wave model, and I'm wondering, instead of calibration, if somebody couples that wave model to a current model and gets a better answer, I think that model would be better than calibrating it. Because if you're calibrating it, you might just change the physics. Which wouldn't be right. I mean, generally we don't calibrate our motion models. I mean, we just stick to the because over the UK shelf seas, so the parameters may vary from one place to another place. So it's very hard to calibrate over a region. But the thing that I've done is that I kept all the parameters as kind of default and then included the tides. Yeah, thank you. Thank you.
Our next speaker is Stefan Kramer. So you can take your place